building homemade speakers that can compare favourably to manufactured units that have all manner of built-in digital signal processors, precisely tuned ports, and computer-calculated internal air volumes is hard. Simple boxes just aren't going to cut it anymore. However, 3D printers might be able to help here. Their ability to make complex shapes with millimetre precision is perfect for making computer-aided designs. But there's a bit of a problem in that thin extruded plastic is acoustically not that great. As it's low in mass, it vibrates and resonates easily, which is awful for sound quality. If this basic enclosure, for example, is measured with a calibrated microphone, we can see this resonance appearing in the 100 to 500 Hz range, and it presents as distortion. Making the chamber walls thicker would of course help here, but it would require a lot of filament and take days to actually print. However, what if we print only a hollow shell and then use it as a form mould instead? Doing it this way results in speedy print times, as the filament only has to be deposited for the shell, with a large internal gap left for a filler material. A cheap and readily available option for this filler material is of course plaster of Paris, which can be added to water to make a paste that sets hard. It does have a problem for sound applications though, in that it's a very brittle material, giving it a ringing quality a bit like a teacup. This has the potential to sound worse than the plastic alone, but there is a way to fix it by adding PVA glue during the mixing process, which changes this quality entirely, and the difference between the two is night and day. I believe the addition of PVA creates a microscopic level of flexibility, reducing its brittle nature and making it behave like a much duller sounding material, perfect for using in our 3D printed mould, which once dried is way more solid than our previous version. These new thick chamber walls reduce the 100 to 500 Hz distortion significantly, which is great, but as the enclosure is so much stiffer now, there's a new problem to contend with: internal reflections. You see, when a speaker driver moves back and forth, it sends sound waves not only forwards towards the listener, but also backwards into the enclosure. An ideal enclosure is supposed to prevent these sound waves from escaping, which our solid enclosure now does a decent job of. But as these sound waves have nowhere else to go, they bounce around and eventually hit the back of the speaker driver again, colouring its output due to the time delay. This is less than ideal, but adding soft materials to the inside of the enclosure is a good way to dampen these reflections. Here I'm going with some soft automotive acoustic pads, followed by a folded layer of cotton towel and then some sheep's wool, which will all act together to stop the sound waves from being reflected back. And overall, compared to our original thin enclosure, we've gone from this to this. Further improvements can be had by utilising higher quality drivers, which we'll be diving into later, but essentially this forming technique has made 3D printing a viable option for hi-fi sound quality, which is really exciting because we can now use their ability to make complex shapes to our advantage. And one area in particular that's going to benefit a lot from this is the subwoofer frequencies. You see, if we replace the enclosure with a long tube, it will keep the rear sound waves contained only until they exit at the other end. Due to the time that this takes, it essentially delays the audibility of these rear sound waves just enough for them to become additive rather than subtractive to the driver's forward sound waves, which makes far more use of the speaker's energy. One notable subwoofer that's become somewhat of a legend in this configuration, mostly thanks to fellow YouTuber Hexibase, is this 3-inch unit from Tang Band. Despite its diminutive size, it should go down to the low 40 Hz range, which is insane for such a small driver. Calculating the required dimensions for this to be done properly can be done with a piece of software called HornResp, which can map out the predicted response, allowing us to get two key measurements: the tube length and the area of its cross-section. The 1.4 meter length required for this is rather long, so it can be made into a folded configuration to make it more compact so that we can actually print it off with the 3D printer. Again, in an effort to reduce print times, I'm making this design entirely hollow, with the goal being to fill it with our special PVA and plaster of Paris mix. As it approaches 60 centimeters in height, it's necessary to split it up into 3 individual sections so that it can be printed with the widest variety of printers. And as you can see, I've included a sealed enclosure above it all for a dedicated midtone driver, as the subwoofer isn't really very good at reproducing these tones. Filling this whole thing with plaster of Paris can be done through a hole at the top, though it does need to be knocked repeatedly to make sure that there are no air pockets. This makes thick walls around the subwoofer port and the midtone chamber, and it makes the unit extremely heavy for its size, but it does feel high quality for it and very solid. During testing though, I found that subwoofer notes, while extremely deep, weren't as loud as I'd like. Now, being me, I'm not satisfied with this yet. I want to take this design as far as we can possibly go to make it the ultimate 3D printed speaker. And to do this, my conclusion is to add yet another subwoofer driver. This doubles the surface area that's going to be providing bass and should hopefully solve the issue. But it does come with its own challenges, namely that we not only need to find space for the driver itself, but also the port has to literally double in dimensional volume. And if I want this thing to remain the same size, that's going to be a massive challenge. But to be honest, the solution is annoyingly obvious. You see, in an effort to have enough room for the plaster of Paris to form good solid boundary walls throughout the speaker, including those surrounding the subwoofer's port, I forgot to ask myself whether they were all necessary. You see, the whole point of this subwoofer tube is to redirect energy, not contain it. As the end is open, its walls really don't have to be as thick as I've made them, because they don't have to hold in any energy, they merely direct it through. With this in mind for the second attempt, I've decided to remove the need for plaster of Paris for the subwoofer's port entirely, and instead have gone with 4mm 3D printed boundaries, which saves just enough space for the now much wider and longer port. The downside is that it consumes twice as much filament and takes twice as long to print compared to the original, so let's hope it's all worth it. So a few days of print time later and we've got everything printed off, ready to be mounted together. Now this is a relatively simple process due to the way it's been designed and divided up, but we do need some glue. Now this isn't actually for anything structural, it's just to form an airtight seal between the different layers. So let's get to it. That is after useful for research and finding unusual components for my projects from different countries. It's actually quite remarkable how much localization affects search results these days. If all of this sounds good to you, visit nordvpn.com/DIYperksVPN to get signed up with a special deal. It's risk-free with a 30-day money-back guarantee. So again, that's nordvpn.com/DIYperksVPN. Now, time to get gluing. As you can see, the biggest change from the original design is how it's been divided up for the printing process, with smaller individual parts rather than 3 big ones. This has been done to reduce the likelihood of printing failure by them popping off the build plate before they complete, though if you do want to print a set of these yourself, do note that it's still important to clean the build plate and apply some school glue for the best adhesion. Once everything's successfully printed, build platforms 1 and 2 can be glued together first, utilising a couple of H-clips to make sure that they're nice and tight. As you can see, the glue has a tendency to squeeze all over the place, but it's easy enough to wipe away any excess. Now you'll have probably noticed that these pieces have many small discs on them. These are actually centering guides, which line up with the subsequent pieces, making them easy to position accurately. Here I'm adding the bottom part of the subwoofer's chamber, and if we flip it over we can see that there are 4 holes beneath it. These are for 2mm diameter self-tapping screws, which allow us to clamp the pieces together. From here the internal air guides can now be added, starting with piece A. This just needs a thin bead of glue along the bottom, as well as any vertical seams it touches. The guides help a lot in positioning it correctly, after which the screws take over. It's important to ensure adequate glue here for a tight seam, keeping in mind that any spillover can be easily wiped away. This process needs to be continued with all of the internal air guides, which completes the subwoofer's tuning port, allowing us to move on to the midtone chamber. As you can see, this is the only section that has carried over the hollow forming technique, as it's proven so effective for midtone use. For a nice strong link, this final platform can get extra support from the subwoofer's exit port, which, as you can see, has a wiring guide in its top half. There are a total of 4 pairs of wires that need to be routed through this, a pair for the top chamber, a pair for the middle chamber, and 2 pairs for the lowest subwoofer chamber. The holes for these, of course, all need to be sealed up so that no air can pass through. With that done, the hollow cavity below the midtone chamber can now be covered, ready for the PVA and plaster of Paris mix in just a moment. But before we do that, we might as well add the chamber's dampening materials at this stage while we have easy access to it. Again, this is just a layer of 15mm thick automotive acoustic foam, followed by a folded layer of cotton towel, and then some sheep's wool. If you can't find any sheep's wool, by the way, it's worth noting that loosened rock wool can also be used here, which is something that you can find in most hardware stores. All this being done means that we can finally cap the unit off with its top lids, as well as the brackets for the speakers themselves. It's worth noting that these being separate is intentional, as it means that the design can be easily adapted to different speaker drivers. So to finish things off, it's time to make what will hopefully be our last batch of PVA and plaster of Paris. While plaster of Paris is generally safe, it does need to be respected as it can set quickly and generate some heat while doing so. Make sure you read the safety notes in the video's description before attempting to use it. The quantity required for our pour is 750ml of water that's already been mixed with PVA at a ratio of about 10 to 20%. This can be followed with 1 kg of plaster of Paris powder, which needs to be mixed in gradually. Once a smooth consistency has been achieved, it can be poured into the chamber at the back, which completely surrounds the midtone chamber with a solid 16mm thick wall. It doesn't take too long for this to set, after which the rear can be closed up with a little cap. Now technically the enclosure is ready for the various drivers to be mounted, but aesthetically, I think there's room for improvement, especially as not everyone is fond of the 3D printed look, particularly when there are joins that are still visible. But thankfully, there are loads of different techniques that we can utilise to make this thing look really special. To make the joins less of an issue, they can simply be filled and then thoroughly sanded down. While this can be done by hand, it's worthwhile borrowing a disc sander as it saves so much time and it gives a really smooth finish, ready in fact for some paint. Some plastic primer can be used here first, as it gives a good key for the top coat. There are loads of cool finishes available these days, and I'm going with a textured paint that looks a little bit like metal. A far cry from the original printed plastic, that's for sure. Now, if you look closely at the sides of mine, you'll see that I've masked them off. What's underneath? Some beautiful wood veneer. I added this before the painting process by spreading around a load of glue and sticking the veneer on top. Veneer, for those who don't know, is a very slim slice of real hardwood, mine being rosewood. It gives the enclosure a really high-end appearance, particularly when it's oiled, as it brings out the richness of the wood. Lovely. The rapid transformation of how this looks is really quite remarkable, and it's only going to get better from here. To prepare for the mounting of the speaker drivers, the holes for them need some little M3 threaded inserts, which are for screwing them in place. When wiring them up, it's worth noting that the polarity of each speaker needs to be correct, with the red wires going to the positive terminals. One often overlooked but very vital addition is to add a rim of blue tack around the edge before the driver gets screwed in place, as this makes an airtight seal for it. As you can see, they are slightly proud rather than flush, so to make them aesthetically more pleasing, they can be tied together visually with a little bracket. Very nice. So with the 2 subwoofer drivers now installed, it's time to tackle the midtone driver. Choosing a suitable one is somewhat daunting, as there are literally hundreds of different models available, each with wildly varying performance characteristics. In an effort to select the best possible driver for this project, I spent literally days testing various drivers, ultimately settling on this one, which is again a Tang band unit. It's got a nice smooth character to its sound output with plenty of mid-range detail, and it looks really smart to boot. An amazing feature of this driver is that it can actually cover high frequencies as well, so it can pull double duty as a tweeter, which is great for those on a tighter budget. For those who want the absolute best high frequency detail, however, the design does cater for dedicated tweeters, though they'll only likely be appreciated by the most demanding of listeners, so it's your call whether to include one or not, as the speaker can be printed without the hole. Either way, with all of the drivers added, it looks really elegant, and it's easy to forget that it is in fact 3D printed. Now, some people might prefer the drivers to be covered, which is why I've included these holes. They're for a grille, which can be made by gluing some threaded steel rods to some mesh, which can in turn be held in front of the speaker with some 3D printed pegs. You could even paint it black for a different look. An optional extra I've included for hi-fi buffs, by the way, are some side baffles. I embedded magnets for these before the painting process, which allows them to be easily added or removed, and the idea is to provide a smooth surface for the sound waves to spread out on. To describe the effect, it's like the sound gets projected forward slightly with them, but it's only a tiny difference. Still, the option's there for those of you who want it. Now, to get the very best possible sound from this thing, we're going to need some help from our secret ingredient, a digital signal processor. Shockingly, these are really cheap to buy now and can provide 4 fully programmable sound outputs, allowing it to function as an advanced crossover. To make use of it, we can simply mount it into a little 3D printed box along with a voltage regulator for power. It's going to get its audio signal from a phono socket that can be inserted here, alongside a DC barrel plug. This essentially takes the audio signal from the phono socket and internally splits it up into 4 separate signals with specific processing for each. As the board can't do any amplification though, it needs to send these signals to a 4-channel amplifier. The one I have here is a Class AB type, which uses slightly more power than Class D amplifiers, but it has a very low level of output hiss, which can be at annoying levels on so many other amps. There is of course a ready-made chamber for it on the back of the speaker, and each driver wire pair needs to be hooked up to it, being careful of polarity. To aid in cooling, a little shroud can be fitted on top that features a slow-moving fan. The amp can run passively, but when listening to loud content for an extended period of time, it's likely to get quite hot, and the tiny amount of air movement that the fan provides is all that's required to keep it nice and cool, so it's well worth it. The signal processor can be added just below this, and wired up to the amplifier's input wires. Their order doesn't really matter as we can configure them digitally later. The last thing to do is add a cap to cover everything up, which completes the build. Now for stereo, I've made an identical pair, and they look way better than I thought that they ever would, particularly for 3D printed speakers. But do they have the audio quality to match their looks? Let's find out. After giving them power, the first thing we need to do is program the signal processor. This can be done with a free piece of software called Sigma Studio, which has loads of different filters and algorithms. I've spent many hours making a profile that gets the most from this design, and you can find it with the project's 3D printable files, link in the description. To upload it to the DSP, we can simply use a cheap USB programmer. This has 3 pins, GND, SCL and SDA, that corresponds to ones labelled on the DSP, so merely need to be connected together. This allows the profile to be compiled and tested live, though to save it to the DSP itself, the WP pin needs to be bridged to ground, after which the profile can be written to its internal memory. Now if you're wondering what the frequency response looks like, I've tuned it to be extremely flat right down to 50 Hz, where it then tapers slightly to 40 Hz. This measurement is without any boundary reinforcement, as it's been done in the open air, but in a typical indoor location with a wall behind them, they measure flat right down to 35 Hz. This is incredibly deep for such small speakers, and this level of performance is usually only found in floor-standing units or external subwoofers. As these would make excellent gaming speakers, it's a perfect opportunity to show you how vivid their soundstage can be.
Keep left, into right 4, left 4, 80,
Phew! As they're tall and elegant, having them sit either side of a TV is a great alternative to a soundbar, particularly as they'll sound significantly better as well. Here's an example against a much more expensive Bose unit. They can even trade blows with high-end bookshelf speakers as well. If you'd like to build a pair for yourself, you can find the printable components for them in the video's description, though do note that they take about 5 days to print. Now, I can't offer any warranty or support for them, but as you've seen from the video, they're easy enough to put together, and they're well worth building. It's taken many weeks of prototyping to evolve the design to where it's ultimately ended up, and I'd say it's a massive success. We've made them very competitive to manufactured units, and they look good to boot. Now, for my next video, I'm actually going to be doing the first PC build I've done in ages, and it's going to be going underwater. So make sure you're subscribed so you don't miss it, and I'll see you there.